Hello, my amazing students. This is Mrs. A, and I love math. Today, we're on lesson 23 in our Saxon Course 3 book. We're talking about multiplying and dividing mixed numbers. Now, if I had a mixed number, 2 and 1/4, it might look very much like this. Now pretend that all of my circles are the same size and all of my quarter pieces are the same size too. So I've divided into quarters, each one, and I have the whole and another whole. So that's 2 wholes and 1/4 shaded. So that's 2 and 1/4. Now, another way that we could figure this out is to say, how many quarters do I have? I have 4 quarters and another 4 quarters and one more quarter. So I have 4 quarters plus 4 quarters and another quarter. 4 plus 4 plus 1 is 9 over the common denominator of 4. Okay, and if we look at it, and we just count how many quarters, we could say I have 4 quarters and 4 quarters and 4 quarters, in 1/4, 4 quarters and 4 quarters and 1/4. So altogether I have 9 quarters, but quarters means that I'm going to put it back over the fourths. Okay, one more way that we can get a fraction out of a mixed number is by realizing that this is the number of fourths that I have, because each one of the denominators is split into four. Each one of the wholes is split into fourths. 2 wholes means I have 2 fourths already. So 2 times 4 pieces is 8, plus 1 more is 9. I have 9 quarter pieces, so I'm going to put 9 back over a quarter to indicate 9 quarter pieces. So that's another way that we can turn a mixed number back into a improper fraction. Now, how do we go about turning an improper fraction like 9/4 back into a mixed number without too much trouble? Now we know that we could say, okay, well, 4/4 is going to go there, so that's 4. I have 5 left. There's another 4/4 there. We could shade those. So then I say, yes, that's 8/4. So I need 1 more 4th. So there's 1 more 4th. Okay, then I could see by the picture that I have 2 wholes and a quarter left. So 2 and 1/4. But that's awfully tedious and takes a lot of time, and we do not want to have to draw a picture every time. So a shortcut is to say, okay, I'm going to divide the 9 by the 4 2 whole times with 1 left over to get back to 2 and 1/4. So when we're changing them, if we're going from the mixed number to the improper fraction, we would say 2 times 4 is 8 plus 1 is 9 over the common denominator 4, 9/4. If we're going back the other direction, we're going to say, how many times does 4 go into 9? 2 times, 2 wholes, okay, and 2 times 4 is 8. There's 1 left over to get the 9, so 1/4 left over. So you need to practice being able to go back and forth between an improper fraction and a mixed number. Okay, so here we're already ready for example 1. We have 2 and 1/3 times 1 and 1/2. So the book told you already the thing that we need to do is turn these mixed numbers into improper fractions before we multiply. So 2 and 1/3, 2 times 3 is 6 plus 1 is 7/3 times 1 and 1/2, 1 times 2 is 2 plus 1 is 3, 3/2. Now, notice what cancels. 3 and 3 both have a 3. So we're going to divide a 3 out of the top and a 3 out of the bottom, leaving a 1 and a 1. So now 7 times 1 is 7. 1 times 2 is 2. 7 halves is improper. But notice we started with mixed numbers. Convention has it that we always put our number form back into the form we found it in. So we're going to put 7 halves back into a mixed number. 7 divided by 2. 2 goes into 7 3 whole times with 1 left over. So it's 3 1/2. Okay, now take that down. Make sure you copy it, because that is example number 1 in your notes. The more you practice these, the faster they're going to get. 1B says we're going to take 1 2/3 divided by 2 1/2. 1 2/3 is going to be 1 times 3 is 3 plus 2 is 5 thirds, divided by 2 times 2 is 4 plus 1 is 5 halves. But notice we have division. Division by a fraction is multiplication by the reciprocal. So what I'm going to do is I'm going to flip the 5 halves over to 5ths. Keep this fraction the same, 5 thirds. Change the division into multiplication. Division by a fraction is the same as multiplication by its reciprocal. So now 5 cancels 5, and I'm left with 1s where those were. So 1 times 2 is 2. 3 times 1 is 3, and the answer is 2/3. Since 2/3 is proper, the numerator is smaller than the denominator, I do not have to turn it into a mixed number because it's not supposed to be a mixed number. It's already in its proper form. Okay, so let's look at example 2. It says a carpenter is nailing horizontal boards to the outside surface of a building. The exposed portion of each board is 6 3/4 inches. How many rows of boards are needed to reach the top of the 8-foot wall? Okay, now they give you a picture of this in your book. Let me hold it up for you so you can see it. See, he's nailing these little boards down here all the way up this 8-foot wall. Now, we first have to figure out, the problem is 8 feet divided by 6 3/4 inches, but we have a problem. We have feet and inches, and we never want to do math when we have mixed units. So we could either take the inches and convert it into feet, but even easier is to take the feet and convert it into inches. Okay, can you see how 6 3/4 inches would be just a part of a foot? Okay, but if we take 8 feet and every foot has 12 inches, then 8 feet is 8 times 12 inches. And 8 times 12 just happens to be 96 if you know your multiplication facts. So we're going to have 96 inches divided by, now we need to change 6 3/4 into an improper fraction. 6 times 4 is 24, plus 3 is 27 fourths. Okay, so basically when we're doing this, we're counting how many fourths we have. We have 6 wholes worth of fourths, so 6 times 4 is 24, plus 3 is 27 fourths. Oh, so we put it back over the 4. Now, we have a division problem, but we have a division by a fraction is multiplication by its reciprocal. So we're going to flip this over. Now I'm going to erase this up here just so that I have a little bit of room. So let's write this one more time. 96 inches divided by 27 fourths. We're going to flip this one over. 4 27ths, change to multiplication, leave the 96. Now this is inches, and this is also, okay, so this one was inches. Okay, so now we have inches and inches. And it says how many, we got 96 inches divided by 6 2/3 inches. So basically when we divided by the inches are now going to cancel out. We had inches and divided by inches. So our units are not going to double. Our units are going to cancel out. Okay, so now we're just doing the math. 96 over 1 to make it easier times 4 over 27. Okay, so now we're going to have 96 and 27. I'm trying to think if there's anything that I can pull out of 96. I know that 4 goes into 96, but 4 does not go into 27. So 27 is 3 times 3 times 3. There is a 3 in 96, isn't there? Okay, so we're going to divide by 3, and we're going to get 96. That divided by 3 is 3. That divided by 3 is 2. Divide this by 3. We're going to get 9. Okay, so that's a little bit easier, right? So we got 32, 9. There's not a 3 in 32, so I can't cancel anymore. But let's go ahead. 2 times 4 is 8. 3 times 4 is 12. 128 over 1 times 9 is 9. 128 over 9. Now, that's improper. It's the correct answer, but I have to turn it back into a mixed number, don't I? So what we're going to do is 128 divided by 9. 9 goes into 12 one time with a 9 and a 3 left over. 8. 9 into 38 goes 4 times because 4 times 9 is 36. And we're going to subtract, and we're going to get 2 ninths left over. So the answer is 14 and 2 ninths. Now the question was, how many rows of boards are needed? 14 and 2 ninths rows. Okay, look at that. That's example 2. Okay, so far we've gotten all of our examples right. We've done 3 examples. Guess what? That's all there is. We're about to start our practice problems in a minute. Okay, we got this one right, but it said, how many rows will the carpenter need? And so since there's part of a row left, it says the carpenter will need 15 rows. Okay, so I don't know what he's going to do on that last row because he's only got 8 feet, but he's going to have to consider 15 rows when he's looking for his materials, isn't he? Okay, no more examples. Now we have a little cheat sheet, okay? Now, it says on page 156 that to multiply or divide fractions or mixed numbers, these are the rules. If we have a mixed number or a whole number, we're going to first write it as a fraction before we multiply or divide, okay? Then, if we are multiplying, we're going to take the 2 fractions and we're going to multiply the numerators together and multiply the denominators together. Okay, if we're dividing, we're going to change division by a fraction to multiplication by its reciprocal. Okay, so multiplication by reciprocal, we're going to change the problem, aren't we? From division of a fraction to multiplication by its reciprocal. Then lastly, we're going to simplify. And once we've simplified, we're going to turn any improper fractions into mixed numbers or maybe whole numbers if they come out evenly. Okay, so let's look at A in our practice set. What is the area of a rectangle 2.5 inches long and 1.5 inches wide? So here we have it, 2.5 inches long and 1.5 inches wide. So we have inches times inches, and we are looking for area. So aren't we going to have inches squared? Sometimes I don't want to forget my units, and so I'll put my units right at the beginning of the problem because I don't want to forget them. Okay, so remember our first step is to turn everything into fractions instead of mixed numbers. So 2 times 2 is 4 plus 1 is 5. 5 halves times 1 times 2 is 2 plus 1 is 3 halves. Now there's nothing we can cancel. So we're going to just multiply straight across. 5 times 3 is 15. 2 times 2 is 4. That's the correct answer in the wrong form. So we're going to divide 15 divided by 4 is 3 times 3 wholes. 3 fours would be 12. That means I have 3 left over. And now I'm going to bring down my square inches so I don't forget it. That is A of example. Practice problem. Practice problem A. Okay, now let's look at practice problem B. It says a recipe calls for 1 3/4 cups of milk. How many cups of milk are needed if the recipe is doubled? Okay, so we have 1 3/4 cups of milk. Now we're going to double that. Well, isn't doubling multiplying by 2? So we're going to take 1 3/4 times 2. We're going to double it. Okay, now how much milk is needed? So we're going to multiply, but first we have to change 1 3/4 into an improper fraction. So we're going to 1 times 4 is 4 plus 3 is 7 divided by 4. So 7/4 times, and 2, I'm going to just write it as a fraction as 2 over 1. And we do have something that will cancel. Notice we have a 2 and a 4. As long as we have a number on the numerator and a number on the bottom, and there's multiplication here, we can divide the denominator by 2 and the numerator by 2 and make our problem easier. 7 times 1 is 7 over 2 times 1 is 2. 7 halves is the right answer in the wrong form. 7 divided by 2 is 3 with 1 left over. So the answer is 3 1/2. 3 1/2 cups of milk would be enough to make the recipe twice. Double it. Okay, so here we go with C. A tile setter is covering a 5 foot by 5 foot square shower wall. Each tile covers 4 5/8 inches by 4 5/8 inches in square. How many rows of tile are needed to reach 5 feet? How many tiles are needed to cover the 5 foot by 5 foot square? Whoa. Okay, so we have 5 foot by 5 foot. Okay, so that's how big the tile is. Now, the whole shower wall. So now we have got 4 5/8 inches is the tile by 4 5/8 inches. Okay, so how many rows of the tile are needed to reach 5 feet, and how many tiles are needed to cover the 5 foot by 5 foot square? Okay, so first of all, here's our problem. We have a 5 foot by 5 foot wall. The problem is we have feet and inches. So we know that there are 12 inches in a foot. So if we look at this and we say, okay, that 5 feet is 5 times 12, which is 60 inches. So this is 60 inches by 60 inches. And that's going to make it easier right at the start. 5 times 12 is 60. So we're going to change our 5 feet to 60 inches by 60 inches. Okay, so now the problem is going to be, it's an area problem. We're talking about how many tiles are needed to get to the top of the 5-foot wall. But then aren't the tiles going to go the other direction exactly the same way? So if there are 20 tiles going this way, there would have to be 20 tiles going that way. And the area would be 20 times 20 or 400 tiles. Okay, but let's first of all find out what is 60 inches divided by 4. So we're going to find out how many tiles are needed, how many rows of tile will be needed to go up to the ceiling. So 60 inches divided by 4 and 5/8 inches. Now again, we're inches divided by inches. The inches are just going to cancel each other out because notice what they're asking you. They're saying how many tiles are needed, okay? Or how many rows of tiles are needed. There's no units in how many rows of tiles. All right, so now we're going to have 60 divided by, let's turn 4 and 5/8 into an improper fraction. 4 times 8 is 32, plus 5 is 37 over 8. Okay, now we need to change division by a fraction to multiplication by its reciprocal. So we're going to flip over and multiply. So let's do that. Let's put the 8 on the top and the 37 on the bottom. 8 on the top, 37 on the bottom, and change this to multiplication. I'll just put the little dot there. Okay, so now 37 is a prime number. Nothing is going to be able to cancel. Okay, so we're just going to have to go straight across. 60 times 8 is 480. And down here, we have 37. Now, I'm not going to turn that into an improper fraction just yet, okay? Because I'm going to have to multiply that number and square it. So basically, this is how many rows are going to be of this size tile going up to the 5-foot high. So if we look at it, that's going to be a little over 10, isn't it? So basically 480 divided by 37, it's going to be 48 divided by 37 would be a little more than 1, but it wouldn't be 2, would it? Okay, and then we're going to tack on the 0. So I'm not sure exactly what it is, but it is, we'll just call it estimate, maybe 11 or 12, okay? And then we have to basically realize that just as if this was my wall, this is 5 feet going this way, and it would take this many tile rows, then we have to cover this distance, which is also pretend it's 5 feet, and we would have to cover that way. So we would have to have this many rows of tile times that many rows of tile again. So we'd have 480 over 37 squared. Okay, so let's do that. 480 over 37 squared. And since we're going to multiply that both directions, because it's going to be that high and that wide, so we have to multiply them. So we're going to wind up with 480 squared over 37 squared. Okay, now I can end up dividing that. If we did divide that, what would we get? Let's get another piece. Let's get another board because that's big numbers there. Let's see what we would get if we went ahead and divided it. 480 divided by 37. Let's just do it. 37 goes into 481. 1 times 37. We're going to have 110. 37 goes into here. 3, 2 times 90. I think it'll go 3 times. 3 times 7 is 21. Oh, almost 3 times. 9, 11. Okay, so you see, it's 111. It would be almost 13 times. But it wouldn't be. It'd be almost 13. So 13 times 13 would be, because we have to have whole tiles, right? 13 times 13 would be 9, 3, 13, 169 tiles. Okay, so this one was not quite 13, but it was close. It would be 12 and 36/37. So you might as well, if you're figuring tiles, you'd probably round it up to 13, wouldn't you? That's what I would do. Okay, so now we've come on a really easy one. We are going to find the multiplicative inverse, which is just the reciprocal of each one of these numbers. So on D, we have 2 2/3. So first we have to find out what this equals. 2 times 3 is 6, plus 2 is 8. So this is 8/3. So wouldn't the reciprocal be 3/8? Okay, this is 5/6. The reciprocal would be 6/5. To find the reciprocal or the multiplicative inverse, we just flip our number over. And 5 is the same as 5/1. So to find its multiplicative reciprocal or multiplicative inverse, which is the reciprocal, we just flip it over. 1/5. Okay, so you have D, E, and F. Okay, so here we are on G already. 1 1/2 times 1 2/3. The first step is to put them both into a fraction form instead of mixed number. So 1 times 2 is 2 plus 1 is 3 over the common denominator times 1 times 3 is 3 plus 2 is 5 over 3. Can you see something that will cancel? We have a 3 on the top and a 3 on the bottom. We divide them both by 3 to get 1. And that's it. But we got 1 times 5 is 5. 2 times 1 is 2. The answer is 5/2, but shouldn't we put that back into mixed number form? 5 divided by 2 is 2 whole times with 1 left over. Okay, 5 divided by 2 is 2. 2 times 2 is 4, so there's 1 left over, 1/2. Okay, let's look at H. H is 2 1/2 times 2 1/2. We're going to square 2 1/2, aren't we? So we're going to turn this into an improper fraction. 2 times 2 is 4, plus 1 is 5/2 times 2 times 2 is 4, plus 1 is 5/2. Nothing can cancel. 5 times 5 is 25. 2 times 2 is 4. 25 divided by 4, we need to put that back into a mixed number, don't we? So 25 divided by 4, remember 24 divided by 4 is 6. So 6 with 1 left over, 6 and 1/4. And that is the mixed number form of the same problem. Okay, so now we're on I. Okay, here's problem J. We have 1.5 divided by 2 2/3. So we're going to have to put each one in its improper form. 1 1/2, 1 times 2 is 2, plus 1 is 3. 3/2 divided by 2 times 3 is 6, plus 2 is 8, divided by 8 divided by 3. Okay, so we have to realize that this is a division problem instead of a multiplication problem. So we're going to have to change to multiplication by the reciprocal. So we're going to flip this one over, and it's going to become 3/8. 3/2 does not change, but now we're going to multiply. So now we have nothing that will cancel. When it looked like this, it looked like all kinds of things would cancel, but it was division. It would not work. So 3 times 3 is 9 over 2 times 8 is 16. No improper fractions. So we are done with that one. So that one was J. No, I. And this one is J. We have 2 2/3, which will become 3 times 2 is 6, plus 2 is 8. Thirds divided by 1 times 2 is 2, plus 1 is 3. Halves, we're dividing, so we need to write down the reciprocal, change it to multiplication, and leave the first fraction alone. Nothing is going to cancel, is it? 8 times 2 is 16 over 9. We should turn it into a mixed number. 16 divided by 9 goes one whole time with 7 left over. So 7/9. 1 7/9 is the answer. Okay, so that takes care of all of our problems. Let's go to number 1. Here we're on our practice. Here we're on our written practice. That was our practice set. So, number 1, at the wedding, the guests sat on either side of the banquet hall. There were 109 guests seated on the left side. If there were 217 guests in all, how many sat on the right side of the aisle? Okay, so in a church, you've got a left side and a right side of the aisle. So 109 are on the left, 217 people in the auditorium or the church altogether, and how many were on the right? So don't we have that this is the total and this is one of the pieces. So we can subtract 217 minus 109 equals how many are on the right? Okay, so let's subtract. Okay, so let's go ahead and do that vertically. I'll just erase this right here. So we have a little bit of space. 217 minus 109. Okay, so we're going to borrow from there, make that a 17. Take away 9 is 8. 0 take away 0 is 0. 108 people were on the right. Boy, they're really evenly spaced, aren't they? 109 on the left, 108 on the right. That is problem number 1. Done for you. Okay, so here we are on problem number 2. It says visitors to the school website can follow a link to the school's choral pictures. If the website has 250 visitors in 1 week and 3/10 of them visited the choral pictures, how many visited the choral pictures? Okay, so we have 250 total visitors to the website, and 3/10 of them. So I wrote down for you 3/10 of 250 is the problem, isn't it? So remember that of means times. So I'm going to go ahead and put a 1 down here. And doesn't a 10 and a 250 cancel out? We can get rid of divide by 10, and divide by 10 just cuts off that last 0, doesn't it? So now I have 3 times 25 is 75 people visited the Coral website to see the coral pictures, didn't they? Okay, so let's look at number 3. Number 3 says Martin Luther was born in 1483, which was 27 years after the invention of the printing press. In what year was the printing press? Okay, so here we have to go. So we have 27 years after. He was born in 1483, which was 27 years after the printing press was invented. So are we going to subtract 27 years from 1483, or are we going to add 47 years? So basically, Martin Luther was born after the invention. So the invention was earlier by 27 years. So we're going to take 1483 and subtract 27 to get 3. Doesn't work, so we're going to make it 13. 13 minus 7 is 6. 7 minus 2 is 5. And 14. So 1456 would have been when the printing press was invented. Okay, so here we are on problem number 4. 5, 6 plus 1/2. Now remember, to add or subtract, we must get a common denominator. 6 is bigger than 2, but it contains a 2. So what if we multiply 1/2 by something to get a 6 in the denominator? So what if we multiply by 3 over 3? So now we have 5 6 plus 3 6. 3 6 is 1/2, isn't it? Equals 8 6. Now, 8 6 is improper, but it is also not simplified. Okay, so let's just go ahead. Divide by 2, divide by 2, because a 2 goes into both 8 and 6. And we're going to get 4 thirds, which when we simplify, 4 divided by 3 goes 1 time with 1 left over. So 1 1/3 is the answer. Number 5. 5 6 take away 1/2. So now we're going to change 1/2 to 3 6 again by multiplying by 3 over 3. And now we have 5 6 take away 3 6. 5 take away 3 is 2. 6 divide by 2 on the top and divide by 2 on the bottom, and we get 1/3. And 1/3 is the answer. And we have number 6. We have 5 6 times 1/2. And there's nothing that's going to cancel. So 5 times 1 is 5. 6 times 2 is 12. That's our final answer. And I'm just feeling very, very generous today. So I'm going to do number 7. And number 7 is a division problem. It says 5 6 divided by 1/2. Since we're dividing, we're going to flip this one and multiply. So we're going to flip this one over to get its reciprocal. 2 over 1 times 5 over 6. Now something's going to cancel. 6 and 2 will both divide by 2. 2 divided by 2 is 1. 6 divided by 2 is 3. 5 times 1 is 5. Where can I put that answer? I'm out of space. 5 times 1 is 5. 3 times 1 is 3. The answer is 5/3, but 5/3 is improper. 5 divided by 3 goes 1 time with 2 left over, 2/3. 1 2/3, and we have worked 7 problems, plus all of your practices, plus all of your examples. And Mrs. A is tired. This is Mrs. A, and may God bless your day.